In example 17 on page 88, we are told that the function of theta is given by 12 cosine theta plus 5 sine theta. And then we are supposed to write theta in form of r cosine theta minus alpha. We are supposed to write theta in that format. This is part A, and we work on part A first. Now, this is addition angle formulae, expanding the right hand side. We are going to find now, and we can bring on board this one because now we are used to it. 12 cos theta plus 5 sine theta is equals to r, and cos theta cos alpha, cos theta cos alpha, this is minus, so we have plus r sine theta sine alpha, sine theta sine alpha. Comparing the terms, of course, we know this one with cos theta is equals to cos theta, and we can directly go and say that r cos alpha is 12 and r sine alpha is 5. We are now used to that. And of course, if we go the Pythagoras triangle way, the tangent of alpha is going to be 5 over 12. And if this is alpha, this is according to the SOHCAHTOA. Tan is opposite over adjacent, so this is 5 and this is 12. According to Pythagoras theorem, this is 13. So without going through the r squared cos squared thing, we can now tell that r is equals to 13. So yes, 12 cos theta plus 5 sine theta is equals to r, which is 13. But before we go to 13, let us first of all find what is alpha. There is a certain angle alpha whose tangent is 5 over 12. So we go to 5 over 12 and shift turn answer. We have alpha is 22.6 degrees. So that is alpha. So by the time this is alpha, by the time we are talking of writing this in this format, we have r, which is 13, cosine theta minus 22.6 degrees. And that is just like what we are expected to do in part A. We have been able to express this that way. Part B talks of find the maximum value of the function of theta and the smallest positive value of theta at which this occurs. Let us look at what we have. We are supposed to find the maximum value of the function of theta and the smallest positive value of theta at which this occurs. A question we have not seen before. But of course, it is important to know the maximum value of the function of theta. And you know what? Our new function of theta, not the new, it's still the original one, but we have been able to write it in this format. So 13, the maximum value, let's talk about the maximum value of 13 cos theta minus 22.6 must be equals to what? Must be equals to 13. You know why? Is 13. Do you know why? Let us argue. Let me explain this. We know very well if we have the cosine curve, the sine of 0 is 1, the sine of 90 is 0, the sine of no, not the sine, but the cosine. The cosine of 0 is 1. The cosine of 90 is 0. The cosine of 180 is this is 180, which is going to be -1. The cosine of what? The cosine of 270. Let's talk about 270 is 0, and the cosine of 360 is 1. This is 270 and this is 360. So it's 1. So the cosine curve, all of us know, looks like that. This is y is equals to cos theta. You can see the maximum value of the cosine of anything is 1. And for that to be true, the cosine of the highest cosine value is 1. Wherever you go, even if you produce this graph to wherever, so long as for all values of theta, let's say for all values of theta, the maximum cosine of theta is always 1. So for this to be 13, it's therefore mean the cosine of theta minus 22.6 must be 1. If it is 1, therefore it means 13 times 1 is equals to 13. And that is why we are saying the maximum value of 13 cosine theta minus 22.6 is 13. I just felt that I should explain this part to see how we are getting 13. But it is the other part that we must work on. We are told that and find the positive value of theta at which this occurs. The positive value of theta. We are told to talk about the positive value of theta. If the cosine of theta minus 22.6 is 1, then in this range, our theta, which is this one, theta minus 22.6, whose cosine is 1, must be equated to 0 because the cosine of 0 is 1. And if the cosine of this angle, which is inside here, is 1, must be said to be equals to 0 because we know the cosine of 0 is itself 1. Or the theta minus 22.6 is now 360 degrees, which is whereby we find the other cosine to be 1. If this is true, then theta is 0 plus 22.6 degrees. Or if this is true, then theta is equals to 360 plus 22.6 degrees, which is 382.6 degrees. But are we given the range? If we are given the range, find the value of theta for which, if we are given the range between 0 to 360, then this angle must be outside the range. But if we are not given the range, probably it could be correct. But I think that angle must be outside the range in any case. So we can confidently say that the smallest possible value of theta is 22.6. In fact, here we don't seem to be interested with the range. Let us make that clear, because the nature of the question is asking us and find the smallest possible value of theta at which this occurs. Of course, even this was acceptable in the range compared to 22.6. Obviously, theta 22.6 is less than 382.6. So the smallest angle, therefore, the smallest value of theta is 22.6 degrees. And it is important that we note this question is quite important. So follow up, let's make follow up from part A all the way to part B. You realize that this is quite an important question. All right.